I'm Tony Rice. I'm a Principal Security Program Manager in the Office of the CISO. Microsoft Secure Development Lifecycle, or SDL, has been the cornerstone of our security culture for over 20 years. It was first mandated as a company-wide policy in 2004, but its roots go back even further, to the early 2000s, when the rise of internet-connected PCs brought new security challenges. Since then, it's continuously evolved to address new threats, technologies, and more recently, regulatory requirements. Today, SDL is a living framework that is tightly integrated with our Secure Future initiative and directly supports SFI goals of secure by design, secure by default, and secure operations. Just as the SDL has evolved, so has how we govern Microsoft's security standards. At the highest level, we have oversight from the Board of Directors and Microsoft Security senior leadership who drive accountability and set the future direction of our Secure Future initiative work. The Cybersecurity Governance Council, which includes our Deputy CISOs, prioritizes SFI work, and Deputy CISOs are responsible for embedding security into their organization's workflows. Or if they have certain horizontal responsibilities, meaning they are required to drive security of certain things across all of Microsoft, they prioritize and drive implementation of that work. While security leadership sets the vision, the real transformation happens when security is woven into our engineering, and this is why we operate a federated model for the security development lifecycle across Microsoft. This is where the rubber hits the road. The central security team, which is where I sit, play a foundational role and are responsible for defining security requirements applicable to all of Microsoft and for providing insights to Deputy CISOs based on the reporting we deliver. And the engineering group is required to have an assurance team. They partner with my team and play a pivotal role in helping ensure standards are practical and achievable. They also define additional controls specific to their product or environment and drive compliance to all obligations. Our standards leverage organizational learning such as incidents, technology changes, audits, and align with standards and other industry best practice. Our ecosystem uses a suite of tools such as Liquid, a requirement management and compliance analytics platform, the Secure Supply Chain Consumption Framework, and CoQL, to name a few. Let's talk a bit more about our operational model. The central team, part of the CISO's organization, play a foundational role by defining requirements that apply company-wide and providing insights to Deputy CISOs through reporting. Each engineering group is required to have an assurance team which partners with my team to ensure standards and controls are practical and achievable. The engineering group assurance teams also define additional controls specific to their environments or products and drive compliance to all their obligations. Tooling is a shared responsibility, and the team who are best placed to deliver the tooling and automation to the company are responsible for that tooling. A partner team of mine in the CISO organization provide the requirements and measurements platform. And the engineering system team are responsible for controls more directly aligned to the engineering system. We manage our SDL requirements as code in a GitHub repository and have created the change management process around it. Our aim is to have a transparent process and track approvals and updates in an environment similar to how engineers work. Any engineer can raise an issue or a bug against the requirement and launch a round of reviews to drive improvement. With so many regulations and other security obligations, both internal and external, we want our requirements to be both as effective and as efficient as possible. We want a single requirement to satisfy as many obligations as possible. We call this dual compliance. And therefore, each requirement takes into account the technology, external regulations and standards, industry best practices, incidents, threat intelligence, and audits. We research and consider these inputs when updating or creating new requirements, and then create requirements that satisfy all the inputs. We go through rounds of reviews and approvals with SMEs across Microsoft. At every stage, feedback is sought, acknowledged, and where appropriate, actioned. And finally, all intent changes, for example, new requirements or major updates to existing requirements, are approved by the Cybersecurity Governance Council, or DCSOs. Once approved, they are added to the SDL and operationalized. Microsoft's SDL baseline consists of 99 requirements and includes requirements for areas such as the engineering environment, requirements for our CI/CD infrastructure and pipelines. For the software security supply chain, requirements for our consumption and monitoring of open source. Secure by design and threat modeling. Coding requirements and mitigations, such as how to safely handle user input and use of toolchain versions. Security testing For example, static, dynamic, fuzz and penetration testing are all included in the SDL. We have requirements for cryptography. We have requirements for operational security, such as the use of multi-factor authentication and just-in-time access, monitoring and response, and of course, training. No security program is complete without training. When it comes to implementing and measuring these 99 security development lifecycle requirements, our focus is on making security requirements practical, actionable, and automated for developers. We build controls directly into our platforms, favoring policy-enforced zero-config tools, and where required, we provide clear guidance so engineers know exactly what's expected. While threat modeling is important, secure design also includes reviewing specialized areas like cryptography and AI. We mandate the use of certain libraries for areas that are hard to get right, such as encryption, authentication, and authorization, and support this with engineering validation where possible. Clearly, engineering automation is essential to scale and coverage for any company. We use static and dynamic analysis tools, supply chain security checks, and integrate security at every stage from IDE to build and deployment. And when driving action, we interrupt developer workflows only when critical issues need remediation, helping teams fix problems fast, not just flagging issues to them. We want compliance to be a natural exhaust of our work, and compliance measurement, evidence management, and executive reporting are integrated into and connected to our engineering processes management tools like Azure DevOps and GitHub. Ultimately, our goal is to drive action and measure progress, ensuring security is built in from the start and tested and validated where it makes the most sense and as early as possible. Now let's look at how the SDL is put into practice across 3 dimensions: secure defaults, data-driven KPIs, and human-driven activities. Secure defaults. These are the controls and processes built into our engineering platforms so that security is enforced automatically without requiring teams to opt in. Examples include pipeline templates that mandate the use of certain analysis tooling, enforcement of 2 code reviewers for every change, and the centralized code signing platform. These are just examples. The goal is to make the secure path the easiest path for engineers, reducing friction and ensuring consistency. Data-driven KPIs. We continuously measure and track key performance indicators to monitor SDL effectiveness. Examples here include identifying driving remediation of open source vulnerabilities, identification of missing or misconfigured security baseline, and driving the resolution of security issues discovered through the SDL processes and automation we've discussed. This data-driven approach helps us identify gaps, drive remediation, and report progress to leadership. And finally, human-driven activities. While automation is essential to scale, some aspects of SDL require expert judgments and manual review. Examples include compliance assessment for requirements that have not yet been automated, threat modeling session, and fuzz testing. These activities focus on the most critical scenarios and assets, ensuring the nuanced risks are addressed beyond what automation can catch. Let's walk through the conceptual model of the Security Assurance Governance Ecosystem, or SAGE. The fundamental objective here is to ensure that every product and service is continuously validated against a set of well-defined security requirements. For each requirement, we communicate clear, actionable guidance to engineers, specify where and how it applies, and detail the methods for ensuring compliance. This isn't just about ticking boxes. It's about making sure that security is embedded in every stage of development and operation. Now let's break this down into practice. We track product or service compliance status against each applicable requirement. If a product falls out of compliance for a specific requirement, perhaps due to a critical security issue that hasn't been resolved within its SLA, we immediately trigger an action for the responsible engineer. This ensures the issues are serviced and addressed promptly and don't linger unnoticed. Non-compliance is also reported to the compliance team for oversight and escalation if needed. However, when a requirement is in compliance, we avoid servicing unnecessary alerts to engineers. This helps reduce noise and allows teams to focus on what truly needs attention while still maintaining robust reporting and compliance for teams. To make this system work, we maintain detailed metadata for every product, its type, its life cycle stage, whether it's in development or generally available, for instance, where I can find the source code, attributes to the source code, such as the language that's being used, And if I find issues through central scanning, I can then direct any output to the correct engineer. The compliance engine takes care of that for me. It's how we know what needs to be measured and where to drive action. All this information is stored and managed within our internal systems, enabling seamless compliance measurement, evidence tracking, and action management. The integration supports both internal standards and external regulatory requirements, ensuring we meet our obligations across the board. Ultimately, this model is designed to drive real outcomes by making security requirements not just theoretical, but practical and enforceable. By connecting requirements, measurements, compliance, and action, we create a feedback loop that drives real engineering outcomes, improving security posture and supporting both internal and external compliance needs. Let's walk through an example. We have a requirement in the SDL that's about secrets detection. The requirement is published in the central publishing and tracking tool. Along with this guidance, information about where the requirement applies and the analytics query, or the query and logic by which compliance is determined and action is driven. The requirement is driven through automation and tooling and enforced through policy. However, on the guidance tab, we include information about how an engineer can check should there be a problem. We are able to query the configuration of Azure DevOps and determine the correct policies applied to the repository. We use the services inventory as a separate data source to determine ownership of the repositories, and then the analytics rule calculates a compliance state of a product or service. As I mentioned, Microsoft's SDL is not just a set of policies, but a practical system that drives real action through our engineering workflows. This is an example of how an issue is reported for CoQL onboarding in the central portal used to drive action. The key idea here is that security requirements are embedded or integrated directly into the tools and processes that engineers use every day, rather than relying on manual tracking or separate systems. We leverage automation and data-driven triggers to surface actionable items with engineering workflows. In this example, when a repository is found to be not compliant, such as not being onboarded to CoQL Central, an action item is automatically generated and assigned to the responsible engineer with an assigned due date. This ensures remediation is prompt and that issues do not linger unnoticed. Clicking on the link delivers more detailed guidance, including a co-pilot experience on how to resolve this issue. Once resolved and confirmed by the data the tool produces, in this case CoQL Central, the action item will automatically resolve itself and be removed from the engineer's work. The same underlying data is also consumed to produce a compliance measure. As expected, because there was an out of SLA action items for onboarding to CoQL scanning, the compliance measure is not compliant, signified by a red circle with a cross. This is using the same underlying data as the action view. The difference here that both compliant and non-compliant repositories are displayed, which provides a more complete picture and greater visibility and insight to overall compliance. A co-pilot experience is provided to direct actions and help resolve the issue. And the co-pilot experience is also available in the action view for engineers to complete their work. When it comes to assurance, we are working towards providing information to both internal and external stakeholders that help support compliance claims through transparent and traceable evidence. Within Microsoft, we ensure that every step of our SDL process is transparent, visible, and auditable. This means that every requirement we generate assurance artifacts and link to evidence that supports compliance claims. These artifacts can include links to automated reports, logs, test results, and manual assessments, all of which are stored and managed in our internal systems. And we can group requirements together and produce evidence for SDL collectively. By making this evidence readily available, we empower compliance teams, auditors, and engineering leaders to verify the security requirements are being met and to identify areas for improvement. This approach not only supports internal standards, it also helps us demonstrate compliance readiness. Ultimately, transparency and robust evidence management are what allow us to confidently assert that our products and services are secure, backed by real data, not just policy statements. This is a foundational element of our SDL governance model, ensuring that security is not just promised, but proven. As we wrap up, let's focus on some key takeaways that drive effective SDL governance and implementation across Microsoft. First, and this is Security 101, just as it is for infrastructure assets. An accurate, complete and categorized inventory of development assets is foundational to effective security, and it provides the foundation for automation. Without knowing what we have, we can't automate assurance or scale our security processes effectively. Second, scaling assurance functions requires investment in both processes and technical control automation. It's not enough to have policies. We need automated controls and processes that work at scale across thousands of teams and thousands of services. Third, to drive effective remediation, we must meet developers where they are in their development lifecycle and their workflow, shifting left and integrating it into their daily workflows. This ensures issues are addressed early and effectively without slowing down innovation. Fourth, human-driven security reviews remain essential, especially for the business's most critical scenarios and assets. Automation gets us so far, but expert judgment is needed for nuanced risks and high-impact decisions. And finally, measurement is key, but we shouldn't let perfect be the enemy of the good. Progress matters, and incremental improvement in measurement and remediation drives real security outcomes. By combining accurate asset inventory, scalable automation, targeted human reviews, pragmatic measurement, and developer-centric remediation, we create security environment that's moving us from policy to practice and delivers more secure products and services to our customers. Thank you.